Here's an example of an application of these particular corollaries. So this example says, to estimate the height of a Douglas fir, Jan positions herself so that her lines of sight to the top and the bottom of the tree form a 90-degree angle. Okay, it says her eyes are about 1.6 meters above the ground, and she is standing 7.8 meters from the tree. What is the height of the tree to the nearest meter? Okay, well, it looks like, you know, they said that we've positioned this so that it's actually a right triangle. Okay, it says, you know, Jan positions herself so that her lines of sight to the top and the bottom of the tree actually form a 90-degree angle. So what they're saying is this right here. Okay, and so since this is a right triangle, we know we have the altitude here, and then all those things actually follow from there. Okay, and so they actually labeled this up really nice for us. Okay, they took the 1.6 meters above the ground part and they gave that to us. They took the 7.8 meters from the tree. They put that part in the diagram for us right there. Okay, so really we don't have a whole lot to do in this problem. Okay, but we're going to call this segment that's from the sight line to the top of the tree, we're just going to call that part x. Okay, and now we can use that first corollary where it says if we have this right triangle, that this altitude is going to be the geometric mean of the product of those two segments that it actually forms with the hypotenuse, okay, of this length and this length. Okay, well, so we can actually just set this up like this. We know that 7.8 is that geometric mean, but we're going to take that, we're going to take 7.8 and square it, and that's going to be equal to this 1.6 multiplied by x, which remember, x is that distance from the sight line to the top of the tree. Okay, I'm even going to write that down. I'm going to say let x equal distance from sight line to top of tree. Okay, and so that's going to help us out quite a bit here. Okay, so at this point we got to figure out what 7.8 squared is. So 7.8 times itself is going to give us 60.84. So 60.84 is going to be equal to 1.6x. And now I'm going to divide both sides by 1.6 here. And I'll get the fact that x equals, I get x equals 38.025. Okay, that's great. Remember, but it asks us what is the height of the tree to the nearest meter. Okay, so we have to take this number x that we actually got here, and we have to add 1.6 to it. Okay, we have to add 1.6 meters to that. So when we do that, we'll actually get 39.625. Okay, and they asked us to the nearest meter. Okay, so we can say that the height of this tree is actually about 40 meters. Okay, so kind of a cool application there. We'll take a look at one more example in the next video where we're kind of using the corollaries of these theorems.